Okay, we have the next keynote coming up, and the next keynote is going to be on data and storage challenges, the use cases, the key pain points in data and storage management, and how SODA can support in solving business problems, and now and in the long term. Let me welcome on your screens. There are 4 sessions as part of this keynote. I'm going to be welcoming each one of them after the session. First up on your screen is Yuji Yazawa, Principal Engineer, Group Manager, and SODA Board Chair, and the SODA EUC Chair. Yuji Yazawa, over to you from the Toyota Motor Corporation.
Hello. Can you hear me?
Yes. Yes.
So, should I share my presentation, or?
If you're comfortable doing that, we can, or we have the slides here. We can do it for you as well.
All right. So, I can't share the screen because other person is sharing the screen.
Yeah.
So,
Ashit, maybe you can stop sharing.
Okay.
Yeah, sure. Now you can share.
Good. Can you see my screen?
But we are seeing the other screen. Yes, it's better now. Yes, we can see the screen.
All right. All right. All right. Hello, everyone. I'm Yuji Yazawa from Toyota Motor Corporation. Let me introduction myself quickly. In my company, I'm doing researching related activities for realize next generation IT environment, which is dedicated for connected vehicles as well as autonomous vehicle. And I also founded a new team for researching for smart cities. And I also responsible for developing and operation for ADS. I mean, autonomous driving system. I actually worked on Yahoo Japan, Fusion IO, and Security, and Toyota. I mean, I born and grew up at storage-related environment for more than 10 years. So this is actually a preliminary assumption for the data capacity came from connected vehicle and the vehicle which have some intelligent function. As you can see, I can't explain too much detail because I can't speak fast, but please see the capacity of the data. I mean, the more than couple of 10 exabytes of data will come from each connected vehicles per month. So, I mean, the automotive related company need to prepare the large storage environment for processing each data came from the vehicle. For example, the vehicle will sending CAN data, which means sensor data. So the data is really small, but we need to process how to say very quickly, like real-time streaming processing, and because of the total capacity of the data is really large, so we need to realize data life cycle management because of the cost reduction. And if we think about the endurance of each vehicle, it actually the vehicle is used more than 15 years or 20 years in the worldwide. So we need to, we need to keep each data for more than 10 years. So if we think about replacing each storage product, we need a tiering or data migration function, as well as because we need to keep exabytes of data. So we need to layer or some cold storage collaboration function, as well as we need to realize security and privacy, such as GDPR or something like that. Also, we already using a couple of public cloud environments, so we need to realize multi-cloud function for connecting each public cloud, as well as our on-premise environment. And we also working with local telco company, such as Docomo or KDDI or ADT or Verizon, something like that. So we but also how we can realize how to say storage collaboration, including edge data environment. So the challenge and expectation for SODA is, from a Toyota point of view, is first of all, cold storage collaboration, because we need to think about how to say, at this moment, we don't have any legal or rule for the data came from each connected vehicle, but if we have a new legal or a new rule for each region, we need to think about we can't delete each data came from connected vehicle. For example, we can't delete the data for 8 years or more than 10 years or something like that. So if so, we need to prepare large cold storage environment for compliant purpose. So at this moment, we are working very hard for realize cold storage collaboration, working on SODA community. So I would say thank you very much for IBM guys and Sony guys and Click2 Cloud guys or some other guys. Also, when I was working on previous company, I was working on storage architect, and I managed a couple of petabytes of storage product. The challenge was data migration and life cycle, because if we think about the operating the environment more than 10 years or 15 years, we need to replace each storage products for each 3 or 5 years. So if we can replace each storage product easily, I think the life must be better. And also, the board member always saying cost reduction. So we need to realize cost reduction as well for putting petabytes of data into exabytes of storage pools. And again, we also need to realize hybrid and multi-cloud using SODA. For real data portability and to realize data from anywhere and compute from anywhere. So that's all from my side. Thank you very much for.
Yes. Thank you so much, Yuji, Yazawa. What we will do now is very quickly move on to the next talk, and we will be taking up the questions for all the sessions towards the end. We'll be directing them to the appropriate panelists. Next up on your screens, we will be having Mr. Xinzong, Chief Technology Officer of China Unicom. Over to you, Xin.
Okay, so I need to share my screen.
Sure.
Can someone release the screen?
Yes,
okay.
Yes, please. You can share your screen now, and you have your video on. All right.
Yeah, can you see my screen?
Yes. We are able to see your screen.
Okay, so let's.
But we are seeing the presentation mode. Can you switch the video to the slide? The sharing. Can you share the other screen?
Can you see my? I turn on the page.
Yes, but we are seeing your presentation mode. So can you change to the other screen?
Okay. So is it okay now?
You're not presenting right now. I think you're showing us the slides. If you start presenting, maybe in Zoom share, you'll have to select the other window.
Okay.
Once you start presenting.
Okay, I think it's okay now.
Yes, it's okay now. Please, sir.
Okay.
Go ahead. Yes.
So, hello everyone. My topic is build the cornerstone for data lake. I want to share some development activities we have recently done from China Unicom. So I'm the CTO of China Unicom World Cloud. As you know, China Unicom is a top 3 telecom operator in China, and as World Cloud, we provide cloud services for customers like big enterprise and government, and we make more than 1 billion revenue every year, and we have tens of thousands of servers which are running open source software like OpenStack, Ceph, and YIG. As you know, YIG is a project in SODA Foundation. Okay, so I think maybe someone have already know about YIG. The YIG project is originated from Ceph. We want to solve some problems for Ceph Redis gateway in the large-scale scenario. So we made a S3 API layer, a gateway layer on top of the Ceph Redis cluster, and we can have different Ceph Redis clusters below the gateway, and which can provide a good isolation for the data rebalance and something else, and also can provide good performance because you can have all the metadata stored in a KV in a separated KV store like TiDB or HBase. Recently, we have, as we know, normally the major S3 providers, object storage, public object storage providers, provide 3.9 high availability for the customers. And if you want to increase the high availability to like 3.9 and 5, you need to do a multi-region deployment, and we have some customer requirements from in this part. So we have we made a project to for the multi-region deployment. We put YIG in 3 different data centers, and which are located in different locations near our main data center in Beijing, and we have the 400 gigabytes upstream link in each data center, and we need to connect interconnect 3 data centers together, and we need to do the load balance between these 3 data centers, so that if one data center is down, the traffic will be distributed to the other one, and we can suffer a downtime for one data center, and we can provide the high availability. I think the challenge for YIG or for the public or private object storage is we want to make the object storage as a cornerstone for all kinds of data. As we know, now the data lake is very hot in China and maybe in the world, and the cloud provider like Ali Cloud just released their product in this area. So we also do some work and make some plans in this area. We want to have all the kinds of data like structured data, semi-structured data, non-structured data, and binary data into one storage, that is object storage. And as we know, the object storage is very good at high availability and high capacity, and very good at the scalability. If you want to do this, you need to have the capability to acquire and distribute the data, and to manage data, and to the capability to analyze the data. So we have a new project on top of YIG to provide more capabilities. So that's our new project, YIG file system. It's a user space POSIX file system based on Fuse. You know, if you use Fuse, you can very quickly have a POSIX compatible file system. So we use the S3 protocol to store the metadata and data. We store the metadata store the data in YIG, and we store the metadata in a KV storage like TiKV or other KV storage which can support the transaction. And we integrate with the Fuse interface so that the user can have you can mount a POSIX file system locally. For this, if you are using this architecture, you will have 2 things. First one, you can have a gateway for YIG. You can have a POSIX gateway for YIG. If the user want a POSIX interface, you can use YIG-FS. And also you can have a good integration with big data framework like Spark, because all the big data frameworks, they have very friendly integration with the POSIX file system. So that's our plan to make YIG a very important cornerstone for the data lake, and we will develop YIG-FS in the near future, and we are hopefully to have more scenarios, maybe from the SODA community and from you guys. You can give suggestions on this new project. Also, we will continue to optimize the performance of YIG. And one engineer from my team will give another topic on the performance optimization for YIG. I think later this afternoon. Okay, so that's all for my part. Thank you very much.
Thank you, Shinzong, for that session. And with that, we will be quickly moving on. Dr. Zia, if you're live, let us know whether you want to take up live or we can play your recorded session.
Anvit, there is some issue with Dr. Zia's network, so we'll play the video.
Okay, so on your screens now is going to be a recorded session, but this is going to be presented by Dr. Zia Saqib, Senior Vice President, Technology, Innovation and Development at Reliance Jio. Ashit, please, could you play the recording?
Issues in video analytics.
Anvit, just confirming the audio is fine, right, for the video?
You can increase the volume, I think.
Increase the volume, please.
So what are we going to talk about is how this data came about in this kind of explosion in the last few years, some use cases and the way forward from our perspective. Now, many studies, including Cisco's visual network indexing, expects that data generation in the video will be the tune of 31% of CAGR, which is compound annual growth rate. If you go back all the way to 2015, you see the growth of video data was in the range of 73,000 petabytes per month. And by the end of this year, it will be in the range of 200,000 petabytes per month, which is a big number by any standards. The question is, where is this data coming from? From what kind of video are we getting this data from? So from the context of Reliance, a group of companies, this kind of data comes from retail, smart agriculture, healthcare, and autonomous vehicles. I'll touch upon a little bit about retail and smart agriculture and healthcare. And in the interest of time, I will skip autonomous vehicles in this talk. When we talk about retail and video surveillance, which go hand in hand, typical data generation happens when we detect text in video and detect human activity, track crowds and recognition of emotions, detection of human activity, detection of gait, etc., which causes an explosion of data to the tune of petabytes. When it comes to data of remote sensed objects, especially in the context of agriculture and geographical attributes, we see there's a big challenge in this kind of data because of the high dimensionality of data. This dimensionality stems from collecting data which is radiated energy from the Earth, being measured by sensors and sensor arrays. And the complexity of this data lies in the sense that we collect this data and tag it in terms of spectral, spatial, and radiometric behaviors of such measurements. So in that sense, it is not standard big data,
but data of multiple dimensions, very high dimensions. And many of these cases, you will not see normal cameras being used as sensors. We use special cameras which are multispectral cameras and thematic mappers. especially in precision agriculture and for planning, crop planning in agriculture. Another area of interest in medical imaging and AI is healthcare and diagnostics. And of course, many steps are involved in analysis of such images, which includes localization of region of interest, segmenting, and characterization of this such images, and using these images and integrating with other modalities such as hospital information systems to construct and reconstruct models. And finally, to be able to estimate parameters of physiology, to be able to make any decisions. A very interesting field of work in this domain, in this vertical, is of course telemedicine, which has picked up quite a bit in the last few months, as we have seen, and a new area which is called a light field based 3D telemedicine system is being experimented across many different groups, and which leads to a big challenge of data analysis and storage from stemming out of this kind of applications. Many groups are working on frameworks and to develop and integrate what we call as light field multi-view coding techniques and integrate them with conventional telemedicine to come up with very interesting applications, especially in the context of rural India. What adds to the complexity of this kind of data is the heterogeneity of data in modality, and then adding to that is the lack of any unified protocol or standard protocol, which makes storage and compute a very big challenge. So, as I said in the previous slide, we are moving towards integration of this cross-domain information, which includes images and image analysis and other information, as I mentioned, from hospital information systems, natural language processing systems, and even MIS systems, to understand the causes of diseases right down to the genome level. A very interesting and ambitious application. So in that context, we are developing, or rather we have come to close to developing a system to detect and diagnose 7 different eye diseases using multi-view coding and machine learning. There's a potential of 250,000 digital service centers which will collect eye images across rural India. In a similar context, if you look at a scenario in a hospital where there's a need for monitoring patients, a single recorder or camera can produce up to 2 gigabytes of data per day. And if you take a typical installation of cameras in a network of hospitals, 100,000 cameras can generate 200,000 GBs per day. Excuse me for missing out 1 0 from this, but it's to the tune of 200,000 GBs per day. So what do we do to face and address these challenges? We are working to develop a framework in collaboration with academic institutions and some open source projects. A few of these projects and academic institutions are as follows. One very famous group from Stanford University called Scanner. Another one from Oxford University called the VGG group, which is very well known for the VGG 16 and 19 and that sequence of architectures, and Deep Video Analytics in California Institute of Technology. And of course, another very well-known group called Kitware, although not being academic, is very active in this area. So what we have seen in last 5 years, the development of many high-quality libraries being available in the public domain, such as TensorFlow, Theano, Proj, MXNet, PyTorch, and so on and so forth. And on the other side, we have seen many very good quality pre-trained models such as Inception, VGG, ResNet, for detection, YOLO, and RCNN and single shot SSD. For face recognition, we have FaceNet, MTCNN, and so on and so forth. Similarly, for semantic segmentation, we have MultipathNet, FCN, and many more. What we also have seen is a deluge of publicly available datasets, okay, such as Kitty, Udacity, Car dataset, Caltex, Pedestrian dataset, Stanford's Drone dataset, Thumos, Yahoo's Flickr, Creative.com, and so on and so forth. And perhaps there are tens and maybe hundreds of such datasets, very good quality and available freely. The problem is each of these datasets has own JSON or XML format, and what makes it absolutely incompatible with each other. So if I'm using Kitty, I'll not be able to use Amos and Thumos in the same context with the same framework. So what do I do is we create an ecosystem using open source software. And what else we have seen in the last 5 years is an excellent container ecosystem which has emerged and which has enabled us to deploy very complex applications. And to add to that ability is the fact that we can add compute capabilities to this ecosystem, which can be built at very small resolutions, such as minutes and seconds. So you pay as you go. And similarly, we have the flexible cloud storage options such as S3, GS, EBS, and GCPD, which makes such a system extremely viable. So a new approach is required, and we are working on this approach, which is necessarily a data-centric approach, which allows us to combine models from different tasks, from different groups, data sets from multiple sources, and then create our own user-friendly interfaces and interactions and workflows. I have a diagram here which shows a typical data-centric approach to this problem. I'm sorry it's not very clear, but I'll explain it anyways. In the center, you have a video image repository along with metadata. Then we have the test queues and the schedulers along with them. We have a file system with images. And on the top and the bottom, we have access or interfaces with indexing and detection and segmentation workers, image processing workers, annotation workers, who can talk to these repositories regardless of their formats and their source. And on the left-hand side, we have an ability to import, export, and ingest data from multiple sources. On the right-hand side, we have APIs using REST APIs and a language called Deep Video Analytics Processing Query Language. This is what we are working on. These are my references. And if you have any questions, I'd be happy to answer them through the moderator. And thank you for listening.
Thank you for the amazing insight on big data storage. We do have a few questions, but I'll be taking them towards the end. Ashit, I think you can mute right at the moment.
Yeah, Anvid, Dr. GI is available for answering the questions if we can. So maybe, as you say, after the slides or in between.
We have one more presentation. We'll take the questions after those.
Sure.
Yeah. So up on your screens now, we have with us Ryan Lian, And Ryan Yang is Director of Product Management Team at Huawei. And over to you, Ryan.
Hello, everyone. Okay. Yeah. Please allow me to share the screen. Yeah. Okay. Okay. Can you see my screen?
Yes, Ryan. We're able to see your
screen. Okay, let's start. Hello, everyone. My name is Ryan, and now work for Huawei as Director of Product Management Team in the data storage domain of IT product line. And before Huawei, I have been worked in Hitachi and Sun Microsystems for almost 80 years. So today is my honor to be invited by the SODACON 2020. And my topic today is the typical challenges of storage management. I would like to share some real use case or projects I was involved in last few years. I hope that we can better understand these pain points, consider this issue in future product design, and provide the optimal solution to the customers. So generally, data storage face three kinds of challenges. Low resource utilization, a number of the storage resources are overcommitted, and the overall resources utilization is less than 40%. Data mobility between storage devices are difficult, and also data value extraction is more difficult. The second is low management efficiency. Complex storage operation and maintenance operations and time consuming and labor consuming. For example, a financial consumer or administrator needs several weeks to develop a storage change solution each time when a new service is rolled out. When the solution is implemented, more than 4 persons are on duty overnight to ensure the storage system works properly. In addition, storage faults has great impact and are slow to locate. In financial industry, service interruption for more than 40 minutes must be reported to the Banking Regulation Commission. So manual root cause identification usually take more than 2 hours. Third is about multi-cloud convergence. It's very difficult. Clouds developed by the enterprise cannot be managed and maintained in a unified manner, forming new storage silos. What's more, it's difficult to utilize enterprise storage capability in cloud. After all, mission-critical workload should be paid more attention on. So what's the ideal storage management? Based on the projects I participate in, mainly in West Europe and China, I conclude and propose this solution as below. So one, from the bottom to the up layer, one or more data center of customer require different media to meet different workload requirements. For example, ultra high performance all-flash arrays are required for mission critical. High performance storage is used in test environment, and large capacity storage with high cost-effective bandwidth is required for backup and archiving system. These storage devices should be centrally managed via a unified interface. Data mobility automatically when required without affecting application, ensuring the business are always online. Second is about OM. OM should be automated and minimize manual operation by administrator and avoid human errors. It's well known that scripting is a necessary skill for administrator. However, the correctness of human errors is well known that depends on the know-how of administrator. In addition, manual intervention is required for script execution, audit, and the final result of confirmation. Human errors are inevitable in this process. To reduce errors, more people are required to review and check the process. Finally, with the reconstruction of data center enterprise digital transformation and the introduction of the cloud technologies, data centers are facing a multi-cloud environment and even have multiple private clouds. In multiple cloud scenarios, storage devices may become new silos. which makes storage management more difficult. How to balance storage resources among multiple clouds and manage storage resources in a unified manner also needs to be concerned. Therefore, the ideal storage management should be pooled, automated, and open to meet customer requirements. I'm going to elaborate on this with a few new projects and use cases. The first case is based on the storage binding content of a top European carrier several years ago I participated in. The customer wants to purchase and utilize storage resources by tiers. The customer clearly defines different tiers. Each tier contains multiple indicators such as performance, latency, density, and availability. Different tiers support different business workloads. Vendor must provide product based on these indicators. In addition, the customer specified the RFP. In the RFP, the management software requirements that must be met for managing these tiers, such as providing service catalogs and using standard API or GUI. The concept of self-service is also emphasized to reduce the daily work of administrator. Business owners are expected to quickly apply for storage resources through the service portal, self-service portal. To meet the customer's requirement, storage vendors should change the criteria for clarifying high-end, middle-range, and low-end products. Evaluate their product capability based on these tiers. What's more, the management software must provide service-level agreement monitoring, root cause analysis, and quick self-healing functions, even metering and charging to meet customer requirement. Still the same customer, except for the clear tier definition, the requirement for data lifecycle management are also raised. Two typical scenarios. First is the production data must meet the basic requirement of industry data protection and must be backup and archived periodically. The second is when the performance doesn't meet the service level agreement, the tier level is temporarily increased or then the tier level is decreased after peak hour, maximizing the resource efficiency. Meantime, ensure the service are not interrupted and the entire process is automated. These requirements seem to be very common. However, to meet these requirements, I think there's still a large gap in current capabilities. The second reference is a commercial bank in China. The main challenge here for service provider is how to integrate and interconnect with the customer existing management platforms. The original purpose of the customer is to prevent vendor locking. In fact, in user current network, there are products from multiple storage vendor, such as EMC, NetApp, and also Huawei. Customers don't have enough development capabilities. Based on the play point in routing, operation, and maintenance, customer introduce various open source management software and customize open source management software to meet their requirements. Currently, alarm monitoring, initial resource allocation, and the capability and the capacity expansion are deployed on separate platforms. Resource management and the performance analysis are also deployed on different platforms. So for a new storage vendor, it's not a small challenge to enable customers to use your products, but also to provide a standard interface to interconnect with these platforms. Sometimes on-site professional service is also required. Frankly speaking, the customer has complained about multiple scattered platform and hopes to gradually aggregate them into one or two platforms to reduce the number of logins and page openings. The last case is a famous European car maker. Customer purchase storage devices every 5 years and expand the storage vendor to bid based on the PAYU model. pay as you use model. So that's kind of new business model. Storage vendor provides and own storage devices. Customers pay for storage devices based on the actual used capacity. Vendors are also responsible for the device maintenance and upgrade. A better way is to cooperate with local service provider than to provide the service to the end user. Customers only care about whether the storage devices meet their performance and security requirements. Let's take a look at architecture. Alarm management and resource allocation management are the most important modules in this architecture. Resource allocation needs to be integrated with existing storm and ice storm scheduling system of the customer. The ice storm scheduled SAN resources, while the storm distributes NAS resources. The upper layers need to be connected to the customer's order system. In this way, the customer can pay on demand by the end of each month. The customer has more than 40 data centers around the world, and 85% of the tasks are executed automatically. Therefore, powerful cross-data center management and automatic scheduling capability are also necessary. For storage vendor, provide high-quality array products is the only first step. How to integrate the storage array into customers' existing resource management process and provide accurate service level agreement management is more important. Look back at these three examples above. These are true stories from the carrier, financial, and the large manufacturing industry. They share a common desire to simplify management with some nuance. However, customer wants to use the most cost-effective storage array and avoid vendor locking. Each storage vendor should provide standard API and even professional service to integrate into customer existing management platform. In some special scenarios, data should be able to migrate smoothly. Customer can quickly migrate data from one vendor to another. Capacity balance can be achieved in multi-cloud environment or multi-management platforms, and the resource utilization can be maximized. These are customers' real pain points and requirements. Therefore, storage provider need to provide comprehensive product and technical support. That's all I want to share today. Thank you.
Thank you so much, Ryan. Thanks for that amazing talk. And with that, we have come to the end of this second keynote. I have one question. I think Dr. Zia, maybe you could just take this one. We have a question which was posed. One of the most pressing challenges of big data is storing all these huge sets of data properly. Most of the data is unstructured and comes from documents, videos, audios, text files, and other sources. How to fix this challenge? Dr. Zia, are you still available on the stream? I believe we may have lost him there. All right. With that, let me thank our esteemed keynote speakers, Yuji Yazawa, Shin Zong, Dr. Zia Saqib, and Ryan Lian.